Hi everyone, I'm Malini Uthayakumaran. Now I am going to demonstrate of my algorithm implementation in the assessment task 2. For my assessment, I have worked on decision tree using C4.5 algorithm. A decision tree is a flowchart and can help us to make decisions based on previous experience. Also, it assists in decision making and provide the best suitable way to take the decision efficiently. There are several ways to design decision trees, including algorithms such as CARD, ID3 and C4.5 that perform differently as the mathematical functions are different for each of them. The C4.5 algorithm is used in data mining as a decision tree classifier, which can be employed to generate a decision based on a certain sample of data. It can work with both discrete and continuous data. And C4.5 can handle the issue of incomplete data very well. And also the algorithm inherently employs single pass pruning process to mitigate overfitting. This is the procedure for my algorithm. It's a flowchart. They utilize an approach of converting the continuous data into categorical form, further expanding the tree conventionally into branches and leaves. Use the concept of information entropy for the curation of decision in the decision tree. The first step is to calculate the entropy associated with the whole attribute column and then each feature of an attribute. These entropy values are in turn used to evaluate the information gain of all attributes. The attributes with the highest information gain is said to be root node. For my assessment, I have used this dataset to find the type of food edible or not in America's Midwest states. It has 5 attributes. There are name, age, apple pie, potato salad and sushi. Each entry has answer to a series of questions about if they like that food, in which the participant answered 1 for yes and 0 for no. The last column, Midwest, is our target column. After the data collection and importing libraries, another process proceeds with additional action with reviews to provide the data set stored in the memory. Data loading is copying the data from the data set into the memory in a suitable format. The data loading process is performed using pandas, in which a CSV file is read in the form of data frame using the read CSV function. After the data loading, I have assigned x1 was the list of first attribute apple pie, x2 for potato salad, x3 for sushi. Then I convert my list of input values to NumPy arrays. Also convert my target column list of Midwest also to NumPy array. Entropy is used as a way to measure how mixed a column is. Specifically, entropy is used to measure disorder, and the entropy of a data set is the measure of disorder in the target feature of the data set. This is the formula that was used to find entropy of the attributes. The next step is to find the information gain, Ig. Its value also lies within the range 0 to 1. Information gain helps the tree decide which feature to split on. It calculates the reduction in the entropy and measures how well given features separate or classify the target classes. The feature with the highest information gain is selected as the best one. Our goal is to find the best variable column to split on when building a decision tree. Eventually, we want to keep splitting the variable or column until our mixed target column is no longer mixed. For instance, let's look at the entropy of the Midwest column after we have split our data set on the potato salad column. Above, our data set is split in two sections. On the left side, everyone who like potato salad. On the right side, everyone who doesn't. We will focus on the left side, which is now has 7 people from the Midwest and 2 people who are not. Here is a split on sushi attribute. Our left split has 2 people out of 6 from the Midwest. The right split has 8 out of the 9 people from the Midwest. This was an efficient split and lowered our entropy on both sides. If we were to continue, we could use recursion to keep splitting each split with a goal to end each branch with an entropy of 0. We see the variable or column with the highest information gain is sushi. Training set is the one which we train and fit our model basically to fit the parameters, whereas test data is used only to assess performance of model. Training data is output is available to model, whereas testing data is the unseen data for which prediction have to be made. Test size is 0.2 means I took 80% of training and 20% for testing. Challenges and solution in the algorithm implementation. C4.5 algorithm efficiently helped to perform the regression and classification. Decision tree helps to reduce the time efficiency. Entropy and information gain help to achieve more accuracy results quickly. Hope you liked this video. Thank you for listening.